Myself, Professor Khyati Gupta. Here in this video lecture, we will discuss dose-response relationship. First, we discuss some basic concepts. First is dose, that is amount of drug administered in the patient. Okay, if 500 mg of paracetamol is administered, then the dose of paracetamol is 500 mg, right? Next is response. It is effect shown by the body to a particular drug. For example, paracetamol is antipyretic drug. So response is it should bring body temperature to normal. Okay. What is response? If you administer any type of drug to the patient, his body should show any type of reaction, right? And this reaction is a response. Okay. Here we have taken example of paracetamol, that is an antipyretic drug, right? Used in mostly fever. Okay. Then if you administer paracetamol to a patient who have a fever, then it should lower the temperature of his body. Okay. It is response. Now, how drug response is obtained? Then drug will bind to a receptor and will make a drug receptor complex, and this drug receptor complex will give you a response. In this figure, you can see blue colored is a receptor site and red color is a drug. This drug molecule will lock to a receptor site and will make drug receptor complex, and this drug receptor complex will give you a response. Now, what is dose response relationship? A relationship used to analyze a kind of response obtained after administering specific dose of drug, right? That is a dose response relationship. If you administer a specific dose of a drug, it should show you a response, right? This is dose response relationship. For example, if you administer 10 mg of elaprazole, which is a proton pump inhibitor, then it should inhibit formation of proton pumps at 10 mg specifically. Okay. Now, dose response relationship has two components: dose plasma concentration relationship and plasma concentration relationship. Now, dose response curve. Intensity of response increases with increase in dose, and dose response curve is rectangular hyperbola. In figure you can see on x-axis we have taken dose, and then on y-axis we have taken a response, right? Then the curve of dose and log dose will make a rectangular hyperbola. Okay. So here you can see if we increase the dose, the response will also increase with intensity, right? Now, why dose response curve is rectangular hyperbola? Then it is rectangular hyperbola because drug receptor interaction obeys law of mass action, right? Now, what is law of mass action? Then E means observed effect of drug, right? Is equal to maximal response means E mix, and concentration of drug will multiplication and divided by Kd plus concentration of dose, in which Kd is the dissociation constant of drug receptor complex. Now, advantages of plotting log dose response curves. Right, you can administer dose response curve also, but if you plot log dose response curve, then advantages are here. First is wide range of drug doses can be displayed on the graph, and second is comparison between agonist and antagonist become easier. Okay. Now, what is threshold? A dose below which there are no adverse effects from exposure to chemicals, right? The dose below which there is no any physiological response or no any adverse effect. Specifically adverse effect, that dose is called a threshold dose. Okay, we will discuss this in detail in later of this video lecture. Okay. Now, types of dose response curves. There are mainly two types of dose response curve, right? First is graded dose response curve and second is quantile dose response curve. Now what is graded dose response curve? Graded dose response curves are constructed for response that are measured on continuous scale, right? For example, heart rate. Our heart continuously beats, right? So heart rate measures in graded dose response curve. Okay. Graded dose response curves relates the intensity of response to size of dose, hence used in characterizing actions of drug, right? This curve relates the intensity of response. If you administer any drug, right? For example, if we taken a heart rate, right, then we have to take anti-arrhythmic drug. Okay, if heart beats out of range, right, our heartbeat range is 72 per minute, right, and if our heart beats 100 per minute, right, then we have to take anti-arrhythmic drug. Okay, if you take anti-arrhythmic drug and in a particular dose, then you can count the bits that are decreased, right? So intensity of response will be there. Okay, graded dose response means slight increase of drug brings small increase in the response, right? If you increase slight dose of anti-arrhythmic drug, it will decrease some count of heartbeat, right? And second example we can take is increased dose of histamine causes gradual contraction of guinea pig ileum. Okay, so it is graded dose response curve. Now, very low dose of histamine has no effect and response is obtained only beyond the threshold dose of 20 mg. See here, threshold means here 20 mg is the threshold dose. Below the threshold dose or below the 20 mg of histamine, there is no any physiological effect of histamine or no any adverse effect of histamine. But very high dose of more than 50 mg has no additional effect also. And response remains constant at these maximal levels. Okay. Graded dose response means the pharmacological effect of drug expressed in quality or number such as heart rate by beat and blood pressure by mmHg. Okay. So graded dose response curve measures the pharmacological effects like heartbeats and blood pressure. Okay. Here you can see dose response curve studying the effect of aspirin, in which first plot is the linear plot and second plot is the semi-log plot, right? Here we have taken two plots in which first is the simple plot in which we have taken the dose only mg in mg, right? But in second plot we have dose but on semi-log graph paper, it means dose will be log dose. Okay, so you can see the difference of ED50 and slope, right? In semi-log graph paper you can easily count ED50. Okay, quantile dose response curves. Quantile dose response curves are constructed for those drugs that elicit all or none response, right? So quantile response is all or none response. For example, presence or absence of elliptic seizures. Okay, the answer of quantile response will be in yes or no, right? All or none indicates that a given dose of drug has or has not evoked a certain effect in various subjects under investigation, that is pharmacological effects are expressed in passive or negative. Okay, so quantile dose response curve will indicate all or none effect. If the effect is there, it will answer yes, and if effect is not there, answer will be no. Okay, now quantile dose response curve in which an experiment performed on 100 subjects and the effective dose to produce a quantile response was determined for each individual. You can see in this figure on x-axis dose is there, and then on y-axis number of response is there, right? So here in the first graph it is frequency illustration, and in second graph it is cumulative frequency illustration, right? Now dose response curve will inform you the potency of the drug, efficacy of drug, slope of drug, and variability of the drug, right? This will discuss in detail. First, drug potency and efficacy. Drug potency means what? Drug potency refers to the amount of drug needed to produce a response, right? And relative potency is more meaningful than absolute potency. For example, if 10 mg of morphine is equal to 100 mg of pethidine, then you can say morphine is 10 times more potent than pethidine, right? Second is drug efficacy. It refers to ability of drug to elicit a response when it binds to a receptor, right? For example, morphine produces a degree of analgesia not obtainable with any dose of aspirin. Hence, morphine is more efficacious than aspirin, right? Okay. Second is drug efficacy and potency curve. We understand potency and efficacy by a figure, right? In figure, you can see that log dose on x-axis is there, and on y-axis response is there. Okay, we have 4 drugs, A, B, C, and D. Okay, concentrate on A curve, that is red colored, right? The A drug is more potent and more efficacious, right? Because it responds, it gives response on the small dose and will give effect more rapidly, right? So it is more potent and more efficacious, right? But concentrate on B drug, that is of green colored curve. It is less potent and more efficacious, right? Concentrate on C drug. It is less potent and less efficacious. And concentrate on D drug. It is more potent but less efficacious. Okay. So you can see the efficacy and potency by comparing the drugs, right? Now, slope and variability. Here you can see first figure, effect of incremental reproducibility, in which you can see log dose versus percentage of response curve, right? In which we have two drug, A drug and B drug, right? And we have both the slope. Okay, you can see A drug, which is more potent and more efficacious, right? And B drug, which is less potent and more efficacious. In second figure, variability is increased in dose of data, different for different people, right? Here we have one drug only, which is A drug, right? But for different people, we have different curves, right? So the effect of the drug will vary in different people. Okay. Now, therapeutic index. What is therapeutic index? It is the ratio of LD50 to ED50, and it is used for judging the drug safety. Okay. For that, we should know LD50 and ED50, right? First is ED50, median effective dose at which 50% of individuals exhibit a specific effect, right? If we take 10 patient, right, and we administer a same dose of 50 mg of aspirin, right, in these 10 people, in which if 5 people will react similarly and will react to the effect of aspirin, that dose 50 mg of aspirin will be called ED50. Okay, and LD50 means what? Median lethal dose required to produce death in 50% of individuals, right? If you take any B drug, you can say, right? If the dose of B drug we administer is 30 mg, right? At the 30 mg of B drug dose, if 5 people from 10 people will die, then this 30 mg dose is called LD50. Okay, lethal dose. And lastly, these are the factors that affect the drug response. Okay, first is age. Geriatric patients who have low function of organs, right? For example, a geriatric patient have lower function of their liver and kidney, right? Then if you administer any drug to geriatric patient, right, and he cannot metabolize it effectively because his liver function is lower. Okay, and he cannot excrete 100% drug from its kidney because its kidney function is lower. Then in this type of patient, the drug will accumulate in their body and adverse drug reactions will be there, right? Weight is the factor that affect the drug response, right? If you have studied the calculation of dose in the equation, the weight is there, right? On the basis of weight, we generally prescribe the dose of drug. If the patient's weight is more, then the dose of drug will be more because it will accumulate in the fat tissue, right? Then gender. We all know that male and female have a different capacity on the basis of gender for ADM reactions, right? Therefore, on the basis of gender, the dose of drug will be different, right? Environment. Uh, Environment means if cold is there or the warm environment is there, on depending on that we should prescribe the dose of drug. Fever and shock like conditions, right? So depending upon these all factors we should prescribe the dose of drug, right? So now we have enough idea about dose response relationship. So we ending here our lecture. Okay.